Ready? Mic check. Good. All right. So we'll get the live feed started here in a second. Quick one to introduce myself. So my name is Daughenbaugh. I'm the Area Manager at the Performance Build Center. So for the people who don't know what that is, it's an engine build facility that is located within the four walls of the Corvette plant. Has anyone been on a tour since the tour's been back open? All right, so you all got to come into the shop for the first time on a tour, which is awesome. We're proud to have you and as a guest to do that. So, couple bare kind of base rules, right? So, myself, I know all about the engine build process, our engine builders, questions about the shop, how we do things, but I didn't design the engine, right? So I have an engineering background, technical questions I'm good with around our engine testing, but why the parts are designed the way they are, I won't have that answer for you. And Logan, I'll have him introduce himself.
Yeah, Logan Hardy, I'm a quality engineer at the Performance Build Center, so my job is making sure all the parts go together and function as they should, and if we really have any issues, investigating that to figure out what's wrong with the part and stuff.
Awesome. Rachel, if you want to give a quick, just kind of base level on expectations as well.
Is this thing on? Okay. I'm Rachel Beckshaw. I'm the communications manager over at the plant. So we love coming out and talking to customers and being a part of it. You give us great feedback, right? Some of the things that we do, you even, suggest solutions to problems that we have, and that's all fantastic. What I do want to remind you all is that all of these people, right, are putting themselves a little bit at risk because they're showing off what they do every day. So I ask that you be very kind, right? Not everybody loves to do stuff in front of the public, so we're really lucky to have them. And you know the rules around, you can't answer future product related questions, right? So no sense in asking those things, and if you do, I will politely come by and slap your hand, and then we will continue on with the demonstration. So we're thrilled to be here, obviously. I just ask that, you abide by those types of rules and really focus your questions around the engine build process. These guys are phenomenal, so really happy to be here.
Awesome. Yeah, thanks, Rachel. All right, so quick background on the Performance Build Center and kind of where we stand right now. So we're a two-shift engine operation. We've got about 70 total hourly employees. So we've got engine builders, we have people that run our tests, we have people that team lead and support the lines, and we have people that build the cylinder heads that we'll talk about here in a little bit. So it's a pretty cool shop. You all have been in part of it. Where you walk in the part of the tour to kind of give you a frame of reference. Is the side of the shop that these engines are built on. So that's line 4. That's the two-shift operation of about 30 engine builders. All the engine builders are over here working on that line. 2 of them work on day shift, and 2 of them were building those engines late in the night last night, and are here to put on the display for you this morning. We also build engines for other high-performance GM products. So we build engines for the S08B, we build engines for the CD5B Blackwing. We build 6.2 liter supercharged engines that we send to various marine applications. So there's a wakeboard boats you can get in with one of our engines. And then we're also still building crate engines for shipping performance. So we build LT4 crate engines. And then of course our bread and butter right now is the LT6 LT7. And for today we're going to put on display how we put together the LT6 engine. So next I'm going to introduce, I'll have them stand up as I go. Our first engine builder is going to be Cline. Andrew's been in the shop pretty much the whole time I've been here. I've been in there for almost 8 years now. He's built a lot of the engines across the shop. Next we'll have Ken Johnson, KJ. KJ is one of the engine builders. He's been building LT6 and LT7 engines. Next we have Dennis Salon. Dennis has been around for a short time with us. He's a really good time to have. He's a Corvette owner himself, so he's probably got his car out here somewhere. And then we've got Colton Bush. Colton's going to bring us towards the tail end of the demonstration. So, all right, to get started, let's start with Andrew. So, right now, I'll kind of, remind you again. So, this is for display and demonstration purposes only. So, we're not going to put engine oil onto this engine. We got to take it all back apart. top, which is sitting on the car already in the dunnage, Andrew had to lift this, bring it over and inspect it. I'll have Logan talk a little bit about some of the inspection that the engine builder would do, while he's picking it up.
Yeah, so for the water pump, the main thing we look for is porosity, whether that be on the lower side or within the cylinder walls. And we're also looking for any little extra scratches on any of the machine surfaces. So especially the bearing surface or bearing system out there, that if you have any imperfections in there, the bearing may not see properly. And then also within the cylinder walls, you know, when you have scratch in there, maybe we'll see those test rings. So we're looking for them, they look everything over, make sure there's no debris anywhere on it,
So what Andrew just put there, you can grab one up and hold it for me for 1 second. So these are oil squirters. So on the Gen 5 product, we have a dedicated one. This engine only has 4. So it's a dual nozzle. You can see it on the camera there. Got a dual nozzle oil jet. So that's going to spray oil on the bottom side of the pistons and bores to keep high pressure jets. So you think about it as an oil nozzle jet, just spraying oil on it. So it's connected right off the main oil rifle that Andrew's sticking that down into. And I'll torque those down really quick. So, question was how many engines do we build? Right now we're doing, this side of the house about 60 engines there, between the two ships about 30 a ship. And then on the Gen 5, so when I say Gen 5, that's the supercharged engine side of the house. We're doing about 30 to 40, so we're between 90 and 100 engines a day right now. So the presentation we were last year, we were between 70 and 80, so we've been having a good increase in volume related to the LT6 and LT7 product lines. All right, so next what Andrew's going to come, so this is a dual overhead cam engine, but it actually still does have a cam in the block, so I'll have Andrew hold this up for a sec. So it's a short little cam shaft. It's got 2 sets of loads on it that are a bi-load. And what this does is it goes in and it drives the 2 high pressure fuel pumps that he's going to put in when we flip it over. So we've got an install tool, he's going to slide it through there. And then Logan, we'll talk about really quick what they look for on that.
Yeah, so the inner drive shaft, some of the water looking for any extra scratches on the journals and on the cam loads. Especially on the journal surfaces, any extra scratch, you can take out the bearings that are already pressed into the block. So we'll make sure there's no imperfections on there, and as they're installing it, we'll be very careful so they don't injure cause any during the install.
So we just put our painter plate on front of that so that it can't come back out of the block. So right now we've already got the bearings installed on the engine. You kind of see them, they're really worn because we don't have any oil on them to put together all the time. So, all right, we're gonna roll it over. So on the top side of the engine, Andrew's gonna put in the lifters. So hold one up really quick for me. Or you do not sense it first. Sorry, go ahead, do not sense it. So these are knock sensors, which are basically mini microphones. So they're picking up a knock, which is pre-detonation of the engine. So that's when you have an uncontrolled burn event. So there's 4 knock sensors on the engine. Inside the shop, you have an orientation fixture that we set on it and orients them in the perfect orientations. They all point towards the back of the block. So that the wire harness that we install later in the process all lines up with it. Yeah. So, there's lifters in the block there. So what those are, we didn't take them out because they're a little bit kind of hard to get back out without any oil. So those are what the fuel pumps ring. So you can hold a fuel pump up for me. So that camshaft that we installed would roll on this lower lifter, which would then push up on it and compress that fuel pump spring. And that camshaft as it drives up and down, is what creates the high pressure fuel. So this fuel system runs close to 5,000 PSI fuel pressure in the fuel rails, and that's all generated from those twin high pressure pumps. So it's a good opportunity to talk about a little bit of the twins in the engine. So it's the Gemini program, and as we go through this, there's a lot of twins about this engine. Twin fuel pumps, twin throttle bodies, twin dual red cans, two cans, right? It's a flat plane crank, so it's got two 4-cylinder engines going to this. So there's a lot of really cool, as we go through this, pairs of two on this engine program. All right, we have fuel pumps in. So Andrew's going to come over here to the crankshaft. We'll talk about it here really quick. Logan, you want to talk about bearings and what we're looking for that they will look at? Obviously, we're not putting the bearings in here and on the rack. Hold on one second.
Yeah, so with the crankshaft, there's a QR code on it and then QR code on the block that will scan that before they install it, and then that goes through a matrix based on the turn diameter of the crankshaft, and then the data that comes with the block to choose 1 to 5 different pin bearing options that have different thicknesses, so they can pick the exact one that will perfectly fit that exact crankshaft in the block.
Yeah, so, all right, go ahead and pick up that crank. So we would install the bearings. Some of the air proofing that we have in the process, you can't see because we're on up here, but every bearing has a 2D barcode on it that is correlated to the letter code. And each bearing is 1 micron different, basically in size, or I guess the 1 micron different in each letter code. So if you imagine a matrix of letters this way and this way, when he scans the crankshaft in the block, he might say, I have a size crank pin and a D size crank. It'll come over and say, I need this size bearing. So there's an operator display. The PLC, which is a programmable logic controller, will give a display and show which bearings for the operator to install. You will then install those bearings before it goes the crankshaft down. We've got a fixture that we put on that has scanners, and it scans each of those bearings to make sure that we install the correct bearing shell size into the correct main bearing pad location. So then we put the crankshaft in, so it's a flat plane forward crank. And one of the things about this engine is it doesn't have main bearing pads. So we'll put the LCC on here in a little bit, but you put that temporary blue retainer on there to hold that crankshaft in, otherwise it could fall out as he's rotating the engine back and forth with stuff with pistons. Does anyone have any? Feel free to answer the next questions that we get. So rods are around 2 thou, and then mains are around 1.5 thou, rough numbers, yeah. So we've got about 5 different bearing shell sizes for every bearing. All right, so next, we're going to put in pistons. So our pistons are, really we'll have Andrew hold one up here in a second. So if you're in the performance industry, you'll probably recognize some names. So these are Pankel titanium rods, and they're CP Carrillo forged pistons. So it's a piston guided rod, so that rod you are holding in your hand is really narrow and really light. Part of the reason why this engine can get to 8,600 RPM with that flat plane crank. So really lightweight rod piston. And then as we talked about, we're building a lot of these engines. So that black ring that's hanging on the bottom of that piston is a ring compressor. They come into us that way from the supplier, so we don't have to compress the rings. They come into us ready to basically pull out the dunnage. One of the things that we don't have here is a large piece of equipment is these rods come into us fully torqued down. That's part of the reason they can actually measure the rod diameter so that they can laser engrave a logo, 2D barcode onto that piston, which will also tell us for the bearing size. So he'll stuff it there, put the rod cap on. So it's a dowel rod cap, can't put it on backwards. And then we'll keep going through this. So obviously we're not installing the bearings already in, but we would be, same thing here, the D-bolts are with D-bolt, the piston crack the shell apart. We then hang them, scan every piston, and Andrew, hold the next one, I'll see if I can get it on camera for you. There's a barcode on the end of it, that has, we can zoom in, get close, yeah, so there's a barcode there, and when we get close enough, there's actually a rocket, so one of the rockets, there's a ton of rockets on this engine, there's over 60 of them, and they let the engineer kind of go free and wild with using them anywhere through the program. So the rocket points the piston towards the front of the block as an assembly aid for it. So he would scan those pistons, go ahead and install that, Andrew. He would install those pistons, basically debolt them, scan them, it selects which bearings that we should use, and then we'll scan the bearings and install the pistons. Every piston is married to the bore that it's in. So right now he's working on the left-hand piston, just this cylinder number 7. So because of the flat plane crank, he can actually stuff 2 pistons at a time with the crank in the same orientation. So he'll stuff 2 pistons, rotate the crank, stuff 2 more pistons, basically 180 degree out from each other. So you'll see as he turns this over, you'll see the other crank pins come up with the 2 together. Andrew's done it a bunch of times, so he knows exactly where to put that, so that piston, that fork guide slides right down in the correct angle for him. Logan, is there anything you want to talk about pistons or anything?
Yeah, so this is the same way as the crankshaft or the bearings. We have 5 different sizes. So it's based off the barcode on there, the piston and the crank uses the crankhead as well to know which bearing is the best fit for that individual one. And then once it selects it, they have an order that's marked where each of the pistons go in relation to the blocks, and then there's a scanner that goes on after that checks to make sure each piston's in the right spot. If you're having the bearing correlated to that, it's that terminal, so you want to make sure they're in the right place. So we have air proofing for all of that.
Yes, sir.
Are the pistons and conduits arranged in sets by weight? Or do they all?
They're not.
They're close enough in weight that it doesn't matter?
Yep. So one of the good things about being General Motors, we get all our suppliers to really tight tolerances, and it's like good enough material. Right. So when we go through thousands of them, we've got that extra supply base capable. I don't know the ring yet. That was one of those, I didn't design it, but I don't know the ring yet on. Alright, so now we're going to rotate around to this side, and we're going to install the right-hand pistons. Did anyone else have a question while he's? Yes, sir.
Your supplier, I mean, like the block and the pistons,
Yep.
that's not a General Motors factory, like.
It is not, no, so those are, not a, cast or made by GM, supplies. Yeah. The cranks actually come from Germany, and then the blocks are, it's pre-machined in Ohio.
Is the Stingray,
The LT2 and the Stingray comes out of Taiwan. Yep, Taiwan engine plant. Good questions. Yes, sir. Oh, that's a good question. So the question was, what's the average time to build an LT6 and LT7? So in a normal 8-hour day, on an LT6, every engine operator can build 2 engines in an 8-hour shift. If you take out breaks once, it's 7.2 hours, about 3.5 hours per engine to complete an LT6. LT7, there's more engine content. There's turbos, there's plumbing. We're working on throughput on that, but it's about 5 hours to build an LT7 right now.
so do you cross shift it, like do you start with one shift and finish it the next?
What's that?
Do you cross shift it, do you?
No, so one of the fun, so in case everyone doesn't know, so one of the coolest parts about our engines is every engine has an engine builder nameplate on it. So we obviously wouldn't want someone finishing that person's engine. So between shifts, the engine build cars, just like the one he's building, is actually a production car. We would go park them all, and when the second shift comes in, they go bring all theirs in, and continue on going. So only in very, very rare scenarios, someone has to go be sick for a while or something. We don't want that do the LT4 supercharged small block size. About 45 total engine builders, and then we've got some other operators called AROs, which are kind of cross-functional. They can go build Gen 5, they can build LT6, 7. There's about 5 of those, so roughly 50 engine builders total. So one of the cool pieces of technology that I didn't talk about is the torque tool. So every torque on every engine is done with an Atlas-Copco electric torque tool. So we don't have main torque wrenches. It's an electronically controlled tool that monitors the torque the entire time. So every one of these engines, because I've done a bunch, I can go look at the torque data. I can see the curve on what the torque looks like and evaluate all that data. For the rod bolts that he just did, we actually have a 2-spindle multi-spindle. So it actually torques them both down at the same time as a torque plus angle fastener. It's got a cool piece of technology on it called stop point. It's a tool tracking system. So as you're going and spinning the crankshaft around, it'll only enable the tool if you're on the next piston in the sequence. So you can't accidentally double hit 2 pistons and send the engine out with a loose rod bolt. So, pretty cool technology that's involved inside the engine build process.
How often do you have to calibrate the torque tool?
We do basically every year. So we have an outside come in and they do a full transducer calibration. But part of our assembly process control plan is we do torque checks 100% on an engine at least once a week. So every fastener on an engine gets make sure our torque tools are doing what we think they should every week. All right, so next, so this engine is pretty cool. It doesn't have an oil pan and it doesn't have main bearing caps. It has what's called a lower crankcase. So it's kind of the same things and combined in one. So if you look at that when it's holding up there, so it's kind of having a whole girdle. It's got 10 bolts in it. So same thing here. We would put this into a machine. It would tell us what bearings to put in it. And we're not going to put it on there now because it's really messy, but it goes into a big robot and applies RTB. RTB stands for room temperature volcanization. It's basically a sealant that applies that bead to the engine. This is going to look a little clunky. So in the real process, we've got a lift assist that'll spin the engine over and has guide pins that'll set it down so that he doesn't have to fight it as he's going through. So again, it's one of those things that is not how your engine will go together if you have one of these. So it's doweled and we'll put it in these order. So Logan, is there anything you want to talk about LTC or anything? If not, I'll have it on. So they're a joint pair. So one of the things about it is if Andrew accidentally drops that and dinged it, we can't just put a different one on. So they're a machine paired together, which is part of that engine bearing data matrix we talked about. So you got the upper side and the lower side as part of that bearing clearance calculation. So if you were to damage it, you basically have to tear one down. Yes?
So is this engine going to get redone in the back?
No, this is just our display. Like I would never want to.
Display?
Yeah,
Okay.
yeah. This one just we put together, same one we did last year, and it sits in the corner and we take that car and do this again with it.
Got it.
Yep. I promise you wouldn't want to fire it. Yes.
Is there no sealant or gasket between those 2 pieces?
Yeah. So there is. It's a RTB, so it's like gray sealant that a robot applies. Then we do a laser inspection on it to make sure it's a continuous feed in the correct width. And then that will be on there. But it's a royal paint to clean off, so we don't have it on the display. Okay. So next he's putting in the lower crankcase bolts. So Andrew, if you can hold one up really quick, there's actually an O-ring gasket on it because that oil couldn't get out through those bolt holes. So there's a gasket seal on the bottom of that bolt. In a machine spot base that's going to go against. All right. And then for this, it's a pretty neat torque secure. It won't look like this. We've got 10 spindles. So it's a big multi-spindle unit that will run that LTC down perfectly parallel on the ball, so that it's not walking it down and causing any weird scraping or anything on the bearing. These bolts are they have Loctite on them. These ones don't, but they're also one time for us, one time each one. So it's torque plus angle. So for anyone who's built an engine, there's a torque is really just a matter of friction. So really what you're looking for is bolt stretch. So in the torque tools, so rod bolts, lower crankcase bolts, head bolts, when we get there, it's all torque plus angle. So we're going to target a certain torque, and then we're going to turn at a certain number of degrees, and we're going to have a range of torque that we expect from that, and allow that. So that bolt actually is going into yield. So actually, if we get a bad hit, we call it an out-of-pay rundown, we'll actually replace that bolt. So next, there's a couple pinch bolts, which are just to kind of pinch the rest of the engine together that's not near those main lower crankcase bolts. And go on those down. So at this point, we would do our first piece of test equipment. It's a big piece of equipment we call torque to turn 2. So what it is it will lower down, so on my main point, there's these holes on the back of this orange cart that are kind of a guide. So this big piece of equipment comes down and engages through those pins. It's got an electric drive motor that'll slide in and engage on the back of the crankshaft. Then it clamps it up, and there's 2 accelerometers that'll go on the front of the block and on the rear of the block. So what it does is we'll have the crank sensor, get the crank sensor in already. So he's got it in his hand, so he'll put that in as I'm talking about it. So that crank sensor picks up on the electric wheel, that's how the engine knows the position of the crank. So we'll connect up the machine to that. What it does is that electric motor does first called a breakaway test. Make sure that as you torque that down, if there was a piece of debris or a deformity or ding in the bearing that made that crank kind of seize up, first thing we're doing is looking at the breakaway torque. So how much does it take to get the engine crankshaft spinning a little bit? So make sure that it breaks away free, and then we'll actually monitor the crank sensor data, and I can tell you down to like the 1,000th of a degree the difference of the spacing between every reluctor tooth on that crankshaft. So if in the process we bent a tooth or dinged a tooth or there was any defect on it, we can find that through that test. It'll then run an NVH test, which NVH stands for noise and vibration harshness, which is the 2 accelerometers. So if for some reason we had a missing bearing, a thrust bearing, clacking, anything weird generating a NVH, a noise frequency, we have limits tuned to detect those defects. And then it's also doing a running torque, so it'll kind of just let the engine spin at a low speed, top 150 RPM, and monitor that torque waveform feedback from the drive. So if there's a bearing, again, with debris or anything causing a drag on the crankshaft, we can at that point detect it, and then we would take the engine back apart. So it's kind of the first certification. At this point, it's considered a short block. So a short block is basically block, crank, pistons, assembly all together. So it's kind of short block validation, which is about the end of Andrew's failure. So what he's handling here is called the oil control valve, OCV for short. It's going to go into the front there. This oil pump that we'll put on later is continuously variable. So that oil control valve is what helps control the oil pump to command oil pressure. Next, he's going to put in, so that plastic piece is the bypass valve. So if your filter happened to be plugged or really cold oil for some reason and it couldn't get through the filter, it's got a spring on it, that'll open up to allow oil to bypass the filter. So he'll put that in there. And then we installed the oil filter, so it's an oil filter and cap, so it's not like what you would see on a blue HCL looking filter. So it's a cap and filter insert that we put on. All right.
Is the cap reusable, or is this something that comes on your filter?
What's that?
Is the cap reusable?
The cap is reusable, yep. So it just kind of like a little tension clip that pops it in. So you can pull the cap off, pop the filter out, pop the new filter, and put it back in. There is an O-ring that over time you want to inspect to make sure that it didn't wear, but on the housing itself. All right, so Andrew's got the oil pump. So it's a pretty cool system. So it's driven off of a sprocket on the front, which we'll put on a little bit. But that front section, to Andrew's left is the high pressure pump. So it's a 7-vane pump that actually generates the oil pressure. It's then a shaft driven all the way through the back. You'll have them spin around. There's a screen in the back, and it has scavenge bays. So those are scavenge pumps that are going to suck oil out of the engine. If you think about it, when we put it on, now that that engine's on there, there's no way for the oil to go from passage to passage. There's just a bunch of oil stuck between two main bearing pads. So you think about it, not an oil pan where you pull a plug. So what that scavenge pump is doing is it's pulling a vacuum, pulling all of that oil out and back to the dry sump tank. So a couple benefits in the engine performance. They can pretty much run in a vacuum. So if you think of windage or the crankshaft, you're not spinning through oil or oil vapor. So you can actually have less drag in the crankshaft, resulting in more horsepower. I should have showed on there, it was kind of an Easter egg that they revealed about LT7, but the LT7, this has 6 scavenge bays, the LT7 has 7 scavenge bays, and scavenge is the turbos on the LT7. And on that oil pump, I should have showed you, but it was blocked off on that pump. There was a 7 scavenge bay shown there as a little Easter egg of something more was coming back in the day. So he'll put that oil pump on there. One of the things, Logan, that we hadn't talked about is children and how we do sterilization of all the components.
Yeah, so some of the parts, it's not every part. For example, the Logan LCC, the pistons, the crankshaft, oil pump, we track all the serial data for that, and it gets married to that engine, the E-ware, which is the serial number for the engine. So if we want to change anything, we have to go there and remove that part, rescan the new part, so that way we can keep track of exactly what's on the engine. If later on there's an issue with the part, we can see that exact engine, that exact part based on the serial number. So, especially the bigger, more involved components, it's all tracked through that process. And when the builders come to do it, they have to scan the part, and then the computer system manager runs through there, and then adds that part to that engine serial number, so everything's tied together. So we know exactly what's on it. We can go back later and look if needed.
Awesome, thanks, Logan. All right, so next, as that oil pump went through the front of that lower crankcase, there's a lot of load going to be on as you drive it. So that's a bearing that's going to go on the front of that there. All right. It'll snug that down. And then lastly, we're going to put the oil cooler on. So it's a really kind of thin pancake, so the coolant will flow through that along with the oil to cool the oil down. So it sits down based on the bottom of the engine and just kind of completes that bottom there. There's 2 O-rings that go on that we install that are already on there, and it'll snug that down. One of the other things, I'll talk about is there's a bunch of mandatory sequences. This is one of them. Andrew probably knows it. You won't know these are on, which is one part. But in our engine build process, we have these smart benches. It's this really cool operator display with a torque tool. It's a carbon fiber. They look really cool. And as we're going through the assembly process, all their standardized work shown on there. So